Okay, this is my final version of a mega race with multiplayer support. I'm going to go ahead and log in here, and we have our title screen. This is all similar to Tuesday's version. I really didn't change much here. Menu system still works the same way. Let me start by creating a match on my local machine, which shows you my new lobby. And while I'm doing that, I'm going to join a match on my other computer here. So now you'll see both players in the lobby. If the other player were to drop, they would just no longer be displayed in the lobby. They can rejoin, and they'll be right back there. I'll show you what happens on the other end if the host were to back out of the lobby. It's not quite as pretty as I would have hoped, but it does work. That being said, I'll go ahead and ready up locally. Ready up. Ready on my remote machine, just showing off that I can toggle. Alright, and here we are in the main game mode. Everything is data driven at this point. All the information about the player's orientation, position, that's all getting sent across the network. Speaking of that, how I'm actually managing what gets sent when is I'm using a dead reckoning system, and I'll get into this a little more when I talk about the prediction, but I'm basically using the traditional dead reckoning approach. I'm going to simulate where I should be based on my last input and where I am going to be based on my new input. If there's a big enough difference, I'm just going to send a packet containing my position, velocity, my rotation, and my rotational velocity over the network. And then that makes sure that, so if green, which is the remote machine, were to start moving here, as long as he's moving around, yeah, you see him skip a little bit right there. As long as his position is updating and it's off from what it thinks the other machine's value is, then it'll go ahead and broadcast that. It's getting a little touchy right now. Not sure if that's because I'm trying to record at the same time I'm doing this, or if I'm just having bad luck. It's been a little bit smoother overall. So that's it for the player basic movement. Show off my laser blast here. See if we can hit that guy. There we go. Scored a hit on the remote machine. Now we're going to get the remote to come from behind and beat the host here. So now whenever I'm spawning a new missile, I'm treating that as critical data. Rather than use the critical list, I'm just using the simple built-in reliable data send to just force that packet to go through until it gets through. Another thing I'm doing is every time the player launches a missile, I'm making sure I send their rotation and position at the time they hit that button, along with the packet saying, hey, spawn a missile on your machine. The idea being that that would give me the most up-to-date direction for that missile, so it should be pretty accurate in either player's screen. Alright, more shenanigans with the remote here. Okay, so that's player 2 winning. I'll go ahead and show you another round here. I didn't get into the mines. Let me get into the mines a little bit just to verify that those are working. So plant the mines. That's local. Here's the remote machine going to come in Yeah. Kaboom, baby. Alright. Steer back around. Do some more dancing. And you get the idea. The minds work too. Other things I want to point out that are really nifty. Between rounds, the player's victory count above their life count there, that actually remains constant until the end of the session. Their kills and deaths also remains static until a new multiplayer session starts. I'm going to go ahead and pause here, and I'm going to bail out. Now, if either one of the players does that, either the local player or the remote player, they can pause, hit back to exit, and it'll kick them straight back to the lobby like you're seeing now. So let me go from here back to the title screen. Going to join a match that I create on my remote machine. It's to show you the join menu. Okay, seeing a list of available sessions. Alright, take me back to the lobby. And from here I can ready up, unready, whatever I want to do. Remember I said that if the host leaves, the lobby does something a little funky. What will happen is it'll do this. Oh, there's no one in the lobby. And then the local player is forced to back out into the menu. That was real low on the laundry list of things to actually fix, in favor of trying to get the player movement and collision detection to be a little less rough. I'm going to repeat that process one more time and use that as an opportunity to show off what this thing looks like with high latency and with high drop packet rate. If you go ahead, create a match, join a match. If you start off the game, and we have a nice network session going, you can press the numeral 1 key on the keyboard. That'll increase your latency by 10 millisecond increments. Pressing 2 will reset it down to 0 simulated latency. You can't see it here, but it is actually dumping to the debug log while it's running, so you can verify that it's at a certain latency. Same thing. Press numeral 3 to increase packet loss probability in 5% increments. Let's see. I'm going to set this up to. Let's go crazy. Let's go 25% packet loss and 150 millisecond latency. So here I go. The game is actually fairly playable. It's not much worse for the wear with the latency and the packet loss set to pretty high values. Latency here, 150, isn't too bad, obviously. The packet loss, according to Microsoft's own framework reference, you should be targeting for to tolerate packet losses of up to 10%. And like I said, this is 25, so we're a little bit above where we need to be. Most of the things you'll notice with high latency and packet loss is that control inputs will be a little less responsive. Alright, let me restart that match. Forgot which joystick was which. The control inputs will be a lot less responsive, and you'll notice that player ships will turn and continue to turn for longer than they should. Sometimes accelerate longer than they should. That's more or less matching like what you would expect from the prediction, since we're assuming that unless we're told otherwise, the player is kind of continuing to do whatever the last thing it is that they were doing. Alright. Oh yeah. Now you can see what happens when you crank up the latency and packet loss and still have the reliable missile commands. So on green there you see that there's actually that little bit of a jitter when he fires a missile, and again that's the doing a forced update of the position and rotation when the missile launches. So even if green's position isn't true, at least the heading of his missile should be. Alright, pause this madness and head back. So that's pretty much the game in a nutshell. Not much else to say about it at this point. It was a pretty fun project. Enjoyed working on it, and I'm actually kind of tempted to do some sort of multiplayer functionality for Capstone. So we'll see where we can build off from this, and it's been a pleasure. Thank you.